Welcome to the class of design of arch structure. Today we will discuss about design of footing, design of column footing. Footing are the bases laid on the soil on top of which a structure is erected, right? So thus this is the foundation on which a building or any such structure stands upon. They are made of concrete having reinforcement inside them and are poured into an evacuated ditch or conduit, right? Before the foundation is built, a test is done to assess the strength of the soil bearing capacity to ascertain the types of foundation to be built. Now, there are many types of footings are there, like isolated footing, combined footing, wrapped footing, and pile footing also. So, actually this is the column and this is the area of the footing. Okay, this is area of footing and this is the size of the column, right? Say this is a square column, hence the size or area of the footing would be square footing, right? Today we will discuss about isolated footing. So my design steps would be: number 1, area of footing; number 2, these are the required steps; number 1 is area of footing, number 2 soil reaction, that is also called bearing capacity of the soil, number 3 is factor moment, and number 4 is required depth. So these values should be known from a design, numerical design. Okay, now the given data is your load on the column, say 2000 kilonewton, and size of column is 400 into 400 millimeter. Okay, and bearing capacity of soil is given as 150 kilonewton per meter square, and you have to use M20 grade of concrete and Fe 415 grade of steel. Okay, now we have to find out these 4 parts: area of the footing, soil reaction, factor moment, and our required depth of the footing, right? So in this case our size of footing is 400 into 400, that means it's a square column, so the size of the footing would be also square footing, right? And our FCK is M20 grade of concrete, so our FCK value is 20 Newton per millimeter square, and this is Fe 415 grade of steel, so that's why our Fy value is 415 Newton per millimeter square. Now first of all we have to calculate the area of the footing. Now for calculating the area of footing we have to find out the area. Now the area of the column we have to find out. The area of the column formula is total load act on column divided by soil bearing capacity. Now this total load comes out as the 10% more than the load applied on the column. The load applied on the column is 2000 kilonewton. So if we increase this by 10% of load, then the value would be 2000 plus 2000 into 10 by 100. Right, so this is the total load act on the footing. So 2200 divided by soil bearing capacity. Soil bearing capacity is how much? This is 150 kilonewton per meter square, so 150. So the value comes 14.66 meter square. So this is the area, right? This is the area of the column. Okay, now actually this is not the area of the column, this is the area of the footing. Sorry, this is area of the footing. That means this is the area. Okay, that is 14.66. Now this is a square footing, so from there we can calculate the side of the footing. So footing size would be root over of 14.66. so this is approximately comes how much? 3.28 meter. Okay, 3.28 meter we can write down as 4 meter approx. So footing size is 4 meter per side. That means this is 0.4, this is 0.4, and this one is 4, and this one is 4 also. Okay, so this is the area of the footing and area of the column. Now we have to find out the soil reaction. Soil reaction we define as, this is Q, soil reaction. Now the formula of soil reaction is Pu by A. Now what is Pu? Pu is nothing but total load act on the column into 1.5, that is the factor of safety, divided by the area of the footing. So the value comes, yes, the value comes 225.10 kilonewton per meter square. Okay, 225.10 kilonewton per meter square. So this is the soil reaction. Now number 3 part is we have to calculate the factor moment. Factor moment, to calculate the factor moment, this is the formula. Mu is equal to total load P into B. This P is the value of load acting on the column. That means by addition of the 10% of the load into B, this is breadth of the footing, and L minus D divided by 2 whole square divided by 2. Okay, and this is the breadth of the footing, and this is L, that means the length of the footing, and D is the size of the column, that means the any side of the column. So the P value is 2200 into B. B is the breadth of the column. Breadth of the column in meter is 4 meter, and L is also 4, minus D. D is the footing, column side, that is minus 0.4 divided by 2 divided by 2. Okay, so the value comes how much? Yes, 17820 kilonewton into, sorry, this is square meter. Okay, so this is the value of factor moment. Now last thing we have to solve, we have to find out the required depth, right? The last part of our problem, we have to find out required depth. Now this is the same formula as we can use Fe415 grade of steel, then the formula would be 0.138 FCK BD square is equal to mu. So your mu is nothing but 17820 into 10 to the power 6. If you convert this from kilonewton into meter to newton into millimeter, you have to multiply by 10 to the power 6. So from here you can say our D is how much? 17820 into 10 to the power 6 divided by 0.138 into FCK is 20 and B value is 4, that means 4000 root. Okay, so if you calculate this, you can get the value of your D value as 401 millimeter. So this is your effective depth of the footing, right? So hence you can solve these desired values. Now some steps we have to also do or proceed, like proportion of the footing for column, check for the bending moment and check for one-way shear, check for two-way shear, check for bearing stress, check for development length as well. Okay, in the next class we will continue. So that's all for today now. Thank you.